Today, uh, we are going to discuss about vector. This is chapter. Uh, it is a part of a chapter which name is motion in two dimension. Motion in two dimension. This will help in that chapter. That's why it is a compulsory to complete to discuss about it. There are a lot of topics in this lecture. We will start. We will start with meaning of vector. Okay, now we are starting. In this world there are a lot of quantities, you know. In our world there are a lot of quantities, so those quantities we are going to divide into two parts. So uh, let me say one thing. I have ppt. First of all, I will read ppt, then uh, my motive will be discussing with you topics. So yes, I have ppt. I will read during this lecture, so that we cannot skip any topics, any words, many words. Okay, that's why I will be reading uh, PPT. Okay, so now we are starting from physical quantities. Physical quantities. Look, PPT says physical quantities based on direction. Based on direction. Try to understand. Based on direction. We have two types of quantities. Two types. Based on direction, I'm telling you. So based on direction, how many quantities do we have? So answer is two. Two types of quantity. So first is a scalar quantity, and second which is a vector quantity. Clear? Okay. It is like mind map. Yeah. You can consider it as a mind map. So first we have a scalar quantity. A scalar quantity, and second we have vector quantity. Clear? Vector quantity. Okay. So what is the meaning of a scalar quantity? Look, first of all, you are crystal clear that this is a quantity. The scalar quantity is a quantity. Yeah. So definition. What would be definition? So definition for a scalar quantity is it provides a quantity, whatever quantity you are taking, that quantity, if that quantity is providing magnitude, only magnitude. Okay, only magnitude. Magnitude. Then you can see that quantity is a scalar quantity, because that quantity is provided magnitude, only magnitude. And you know what is a magnitude? Magnitude is a combination of a unit and a number. Okay, so if someone asks to you what is the definition of what is the meaning of a magnitude, then you can directly say yes, magnitude is a combination of a unit and a number. Number plus unit is magnitude. Okay, this was definition about a scalar quantity. Clear? When it comes to vector quantity, we know it provides magnitude plus direction. Direction. Since we are talking about the vector and the scalar based on direction. Based on direction. So here direction will matter. Direction will matter. So magnitude plus direction, there is a one mode which we need to add. But right now, just you understand, yes, vector quantity, if a vector quantity is providing direction plus magnitude, any quantity which is providing magnitude and direction, you can say yes, this quantity, name of this quantity will be vector quantity. Okay, this quantity is coming in the category of a vector quantity. Clear? What did you understand? You understood that there are a lot of quantities in the world, in our world. In our world, there are a lot of quantities. Now we just divided those quantity into two parts. So first part we have a scalar quantity, and second part we have vector quantity. Then we defined it by saying yes, magnitude. If one quantity, there are some quantities who are providing magnitudes. So we can see as those quantities are nothing but a scalar quantities. Clear? Okay. Then we saw vector quantity. We saw that if apart except scalar quantity, there are more quantities who are not providing only magnitude. They are also providing direction. So we thought, yeah, okay, if there are some quantities who are providing direction plus magnitude, then okay, we will call it as a what we will call these quantities as a vector quantities because they are providing direction having magnitude. Okay, I was saying that one point more we need to add for definition of vector quantity, which is law of algebra. Law of algebra. Law of vector algebra. Here, a scalar quantity says that uh, I follow simple law of algebra. Simple. 2 plus 5 7. 7 plus 70 77. This is what is a scalar quantity. Okay, that is how we add quantities. But when you enter into vector quantity, then it says that I will follow law of vector algebra. Law of vector algebra, or you can say law of algebra. Means it is not simple to add any quantity. It is not very simple. We will have to follow one rule, which is the law of algebra. Okay, law of algebra. If a quantity is flowing law of algebra, then we can say yes, this is the exact definition of a vector quantity. Clear? Vector quantity. Look at one. Sometimes you will say yes, a quantity has a magnitude, or you can say direction. Is it enough to say yes, this quantity is a vector quantity? Can you say confidently? A quantity. I am saying that there is a quantity who has a direction. Now I am asking, is it enough to say yes, this quantity is a vector quantity? Answer would be no. Answer would be no. The quantity should have also magnitude. That quantity should follow law of algebra. Then we will say yes, this is our vector quantity. Okay. So one more point which we are adding is also compulsory to us to say that yes, a quantity is a vector quantity. Clear? So law of algebra was one more point, okay, for vector quantity. Now let's see examples of scalar quantities and examples of vector quantities. So examples for scalar quantities, we have distance. Distance does not provide a direction. Temperature provides only magnitude, not direction. Uh, yeah. One more, time. Okay, time is also a scalar quantity. Clear? Mm. Electric current is also a scalar quantity because it follows a simple addition that we are using in our daily life. 700 plus 100 is equal to 800. This type of addition, a scalar quantity follows. Okay, so when you will see uh, what when you will see current, then you will observe yes, current is flowing. Simple addition. Okay, simple addition. This is the meaning of a scalar quantity. Okay, so this was examples for a scalar quantity. Density and volume, all these are also an example of scalar quantities. Now, what about a vector quantity? What about vector quantity? Yeah, we have seen definition for vector quantity, but examples, okay, examples. So examples for this would be displacement, okay, velocity, acceleration, okay, angular velocity, yeah, this is also an example for vector quantity, yeah. So this is enough for now. Displacement, velocity, acceleration, force, all these are examples of a vector quantity. So till here we have to study. Now till here whatever we understood was about a scalar and vector. Okay, a scalar quantity and vector quantity. I hope we are crystal clear about it. Now let's see difference between them. A scalar quantity says that we are described by its magnitude only. A scalar and vector. We are saying what difference between them. So a scalar is defined by only magnitude, but when it comes to vector, we see that vector is defined by having magnitude and direction, plus it should follow law of algebra, not simple addition. Okay. Second point for this, they can be changed by changing its magnitude only. As Karan is saying, we can be changed by magnitude. Changing magnitude. Yeah. If you change it to by, if you replace by 2 by 7, still this will be our magnitude, which is a definition for a scalar quantity. Okay. Now for vector quantity, they can be changed by changing its magnitude, direction, both magnitude and direction. If you change the direction, if you change magnitude, so still it will be definition for vector quantity. I hope you have seen. You are observing difference between them. Now third point, for both, they follow ordinary rule of algebra. Ordinary, which means simple. In other words, if we say ordinary means simple. It means a scalar will follow simple law of algebra. I am saying it from the beginning. Now, they follow for vector quantity. They follow vector algebra. Yeah, they should follow vector algebra. Okay. So last is an example. Examples for a scalar are distance, time, current, density, volume. Yeah, all these are examples of a scalar quantity. Now for vector we have distance. No, displacement. Displacement provides a direction. Okay. So displacement, and also it follows vector algebra, law of vector algebra. Displacement, angular displacement, angular velocity, acceleration, force, torque. All these are examples of vector quantity. Now note. Okay, you have to know. If a vector is a rotator, if we are rotating a vector, okay, through an angle, at some angle, other than multiple of 2 pi, which means 360 degree. 2 multiple 180 is 360 degree. Then it changes. Means if you rotate, look, this is vector A. Direction is like this. This is vector A. If you rotate by some angle, this is theta. What are you observing? Direction has changed. Magnitude is the same. I think magnitude is the same, but direction has changed. So if you rotate any vector at some angle, by some angle, then you will see yes, the direction has changed. This is what will happen. Okay, this is what will happen. So when theta comes, you see yes, at each point vector is changing its self direction. At each point it happens when angle is coming into picture. Okay, at each point you will observe yes, the direction is changing itself at each point. This was very, I would say yes, here when you will see rotation chapter, when you will study rotation chapter, then this point will come, which is a concept. I think so. according to me, this is a concept, a point, I would say, a point. If you don't understand it carefully, then you will face challenges in your rotation chapter. That's why I'm emphasizing on this rotating part. If a vector is being rotated by some angle, then you will see that at each point it is changing its direction. Yeah, it is changing its direction. So right now just we saw a little bit about a little bit discussion about rotational part. Okay, rotational part, which was related to vector. In details you will see in your rotational chapter. Okay, because its direction gets changed, but magnitude remains the same. Here magnitude if is 5 centimeter, then here magnitude will be same 5 centimeter, but direction has changed. Yeah, direction has changed due to angle. Okay, reason is angle K. But remember, magnitude will be same. It is making sense. Yeah, this is making sense. Completely, it's making sense. Okay. Next point, if the reference frame. Do you know what is a reference frame? This is the object, but we take a reference point so that we can find exact location of another object. That's why we take a reference point. Okay. So why do we take reference point? We take reference point so that we can find exact location of another object. I hope you have understood. So it is a, if the reference frame is a translated, it is a motion. Okay, motion. Translation is a motion. It is a type of a motion. If the reference frame is a translated or rotated, if you are rotating, okay, it's okay. The vector does not change. The vector does not change what direction, but it may change its components. Okay, it may change its component, you know, two components of a vector, one x, another j. Okay, so overall it is saying, if you are rotating a reference point, there is vector who is sitting on the reference point, and just the reference point is being rotated. In that case, what will happen? You will see that according to reference point, vector is in rest. According to reference point, vector is in rest. Okay, the vector does not change its a component. Yeah, you will see that here we are taking reference point. If we see carefully, if we observe carefully, then you will see that yes, according to reference point, vector who is sitting on the reference point is in rest. Clear? So you can see as the direction is not changing and magnitude is not changing. Direction will not change it at all. Yeah, because reference point. The whole reason is reference point. Clear? Concept remainder is vector quantities follow vector algebra, not the ordinary law. Yeah, this is a main point. This is the main point for definition of vector quantity. Remember, if you are saying yes, a definition of a vector is it provides a magnitude and a direction, is not enough. Is not enough. You will have to say one more thing, which is a law of a vector algebra. Okay, you will have to add one more thing for definition of a vector. So one more thing is law of a vector algebra. Then yeah, then anybody can't say that you are wrong. Okay, can't say that you are wrong. Clear? Clear. Now, if a physical quantity is a vector, yeah, we have said this. If physical quantity is a vector, it has a magnitude, so it is not enough to say yes, this is a vector quantity. We have to add one thing, which is a vector law of algebra. Law of a vector algebra. Okay, if that quantity is following law of a vector algebra, you can say, brother, that yes, this quantity is a vector quantity. Clear? Clear. So we have seen a scalar and vector with examples. Now, representation of a vector. This is another topic which is related to vector quantity. So representation of a vector. representation of a vector. How to represent any vector in mathematical language, in maths language? Remember, this arrow is used. This arrow is used for representing a vector. What is it saying? It is saying that this segment line represents magnitude. Okay. If you break down this arrow, you will see this is one part and another part is this arrow. So this separate one, which is a line segment. So this is telling you, this is expressing that I am magnitude. Okay, I am magnitude. Okay, only this line. But when it comes to this arrow, it says that I am telling you direction. Clear? Direction. I hope you are understanding it. So this arrow is about direction, this line segment is about magnitude. Okay. So this whole, if we combine this segment line and arrow, what will happen? It will give us vector, a complete vector. Clear? So this is what is a symbol of representing vector. Okay. Okay. So you are understanding this, that this symbol will be used to represent any vector. Okay. For example, this is a, if you apply this symbol over here, you are saying this is a vector. You can call it as a vector. You can replace this a by m. You would say now this is a vector. That is how we call any vector, like that. Okay. Do you know what is it now? What would say about it? What would you say about it? Here we just used this two parallel lines, which is known as a mode, or you can say magnitude of a vector. Okay, this mode is used to remove direction. Remember, this magnitude mode or mode, you can say, it is used to remove direction and negative sign. Clear? And negative sign. Clear? Negative sign. Since this is a vector, let me erase. If I ask you magnitude of a vector will be what? Direct say mode of a vector. That is how you will represent any magnitude of any vector. Okay. So magnitude of a vector will be like this, mode of a vector. Clear? Here we are saying that just result would be magnitude, not having direction. When mode is used, then result would be only magnitude, not having direction. Clear? Not having direction. So magnitude of a vector is always positive. If you are observing that your vector has a negative sign, it means it is a for negative direction, or you can say opposite direction. This is a for direction, which is a negative direction, opposite direction. So remember, this a vector has a negative sign. What are you understanding? Value magnitude is how much? 5 meter per second raised to power 2. Here you are understanding that this minus is about a direction. It is not saying that I am less than 0. No, number is not less than 0. This negative came just for direction. Clear? This negative came just for direction. When it comes to vector, so yes, this is a vector. This is its acceleration. Here negative is working for direction, not for number. It is not saying that I am less than 0. Height is not less than 0. Okay. Okay. So remember, vector is always positive number. Always. If negative is coming, it's about the direction. Yeah, I have told you that here we are applying. If we are applying mode, it means uh, whether vector has a negative or positive sign. Once you apply mode, the this vector, or you can say mode of vector, will be always positive number. That is why we use magnitude. Okay? Once you apply magnitude, it will provide negative number. No, positive number. Now we are going to move to the next point, not next point but topic. To the next topic. Magnitude of a vector is always positive. If a vector is negative, it means negative sign represent the direction of that vector. Clear? Now next topic is which is angle between two vectors. Angle between two vectors. Angle between vectors. Remember, if you are finding an angle, then it is impossible to find angle having only one vector. Yeah, it is completely impossible, brother. So that's why I would say, yeah, you take more than one vector, then it is possible to consider angle between them. Okay. So angle between vectors. First of all, let's read PPT. Okay. It is saying the angle between the two vectors mean a smaller of the angles between them when they are placed tail to tail and head to head. Yeah, what is the tail to tail and head to head? Here, this end side is our head. Okay, and this first, which is initial. So it is our tail. This is what is the meaning of a tail and head. Starting is a tail and final is a head. So here, if a question is providing two vectors, so just you will have to shift parallelly those two vectors, and you shift such that they they should be attached by head to head and tail to tail. I will show. Okay. So the angle, okay, head to head by displacing either of the vectors parallel to itself. You can shift any vector parallelly, but condition is don't change the direction and don't increase or decrease magnitude of any vector. If you are shifting any vector, just shift parallelly. Okay. Don't change the direction. For example, this is a vector which name is a vector. Again a vector. Our focus is on understanding concept of it. So a vector, okay, a vector. Here I am saying shift it parallelly. Okay, I am shifting over here. I want over here. What are you observing? You will observe that magnitude is the same, direction is also same. Just we replace this vector over here. Everything is same. You can see this is a correct way to shift any vector. It can go over here, it can go over here, it can go anywhere on this plane. Okay, on this plane. If you shift it like this, is it correct way to shift this panel or any vector? Is it correct? Answer is no. This is incorrect. Now let me provide a logic behind it. How is it incorrect? It is incorrect because here you can see this vector A. Now it is not vector A. This has changed. Its direction. Magnitude is same, but direction has changed. That's why this is incorrect. Okay. That's why it is incorrect. Clear? Condition is very simple. Don't change magnitude and don't change direction. Yeah. If we don't change the direction and don't increase or decrease magnitude, still it is possible to shift anywhere. Clear? And I have shown it over in front of you. Here you can see just I shifted this over here. Nothing has changed, including direction and magnitude. That is how you will shift. Okay. Once we understand how to shift any vector parallelly, it helps in the topic of an angle between two vectors. Yes, you will observe that this is helping in this part, angle between two vectors. Question is saying that okay. Question is saying, let me write this one. This is what is a question. Question is providing this two vectors, which is like this. This is figure of a two vector. Name of this vector is a vector, and name of this vector is a b vector. Clear? Now it is asking what is the angle between them. This is asking what is the angle between them. Okay. What can I add? One thing, which is here you will see, brother. We have two angles. This is one, and this is a greater angle. One is a small, and second is a large. So which one should we take? Answer is a small angle. Always take a small angle between two vectors. Always take a small angle. Okay. This is one point for this topic. Always take one vector, a smaller angle. Now, let me ask: is this connected to vectors in correct way? Answer would be no. This is an incorrect way. Here our work is to shift vectors so that it can be in correct way. I have told you how to shift any vectors parallelly. Condition for this is, if you're finding angle between two vectors, first of all we know that we will take a smaller angle, and second condition is you will have to shift it if it is a requirement. If it is a requirement to shift any vector parallel, yes, you can shift. So that connection should be correct. Okay? Connection of two vectors should be correct. Clear? Okay. So second condition is both vectors should be attached tail to tail and head to head. Should be attached tail to tail and head to head. You can observe over here. Carefully observe. What are you observing? You are observing here. Both are not connected head to head. This here connection is over here. This is connected by head to tail. Which is incorrect. Incorrect connection. Clear? Incorrect connection. So just shift. Either you can shift this A vector or B vector. Both are right. So I am shifting this B vector. This A vector will be as it, and just this will go over here. This will go over here. This is our A vector and B vector. Now is it correct? Answer is yes. This is correct. Why? Both are attached tail to tail, not head to head. Tail to tail. Both are attached tail to tail. So a smaller angle would be this. This is our smaller angle. So this theta. Let's suppose it is a 110 degree. 110 degree. So angle between these two vectors is 110 degree. Okay. 110 degree. This was one way. Same we can shift Initially we shift this B vector. No, you can also shift A vector. It's your choice. It's your choice. Okay, answer, I think answer should be same. If you play shift this A vector, what will happen? This D will be as it, and it is going downward like this. This was smaller angle is our answer. What happened? Answer should be same. So here we saw how to connect two vectors to find angle between them. So that is how we will find angle between two vectors by connecting in correct way, head to head or tail to tail. Clear? Head to head and tail to tail. Now, next topic, which is a polar vector. Polar vector. Polar vector is a vector. Okay. We are observing types of vector. We are studying types of vector. It is a vector which has initial point or a point of application are called polar vectors. Means. This A vector, look at all. You can see it has an initial point. This is initial point. Can you say that this is a point? No, it is arrow. Show initial point. If a vector has initial point, of course it will have initial point. So this type of a vector is known as a polar vector. So it is a vector has an initial point, which is starting from initial point. Okay. Okay. This was not a difficult to understand it. Okay. This is our displacement, it is a head, this is tail, its segment is a magnitude, arrow is a direction. Okay, arrow is a direction. You can say this is P, this and P, this final end is Q. You can say A vector is equal to PQ and just represent, just apply this arrow. Both are equal. This is a different way to represent any vector. Either you can use A vector or you can use PQ vector. Clear? That's not incorrect. Okay. Next type of vector is axial vector. Axial vector. Axial vector. चूंकि ये वेक्टर है हम पढ़ रहे हैं टाइप्स ऑफ वेक्टर. Axial vector. From this axial vector you can you can understand, yes, this is about rotation. Axis, this is about axis. Okay, this is about axis. So yes, rotation part is coming over here. Rotation part. That will draw a figure. This is the axis. And there is a what? There is a disc like this. This is center. This is a center. It is taught in the chapter of rotation. Right now, just we are taking little bit information about rotational chapter. So axis, where is axis? This is the axis This is our axis. Okay. From this figure, you will see a lot of vector, angular vector, displacement vector, rotation. So first point for this is axial vectors are used in rotational motion to describe rotational effects. Yeah, I have told that this is a part of a rotational chapter, but Just right now we are taking a small little bit information about it because it is related to vector. That's why we are discussing about it over here. So second point for this is the direction of a axial vector is always along the axis. This axis will tell you direction. Who will tell you? Axis will tell you direction, which is our vector. Okay. So direction of axial vector is always along the axis of rotation in according to right hand screw rule. Here we will use a right hand thumb rule. Right hand thumb rule. Look, brother. If this object is rotating like this, like this, so just put your hand like this and then see. You close this fingers like this. What will observe? This thumb is upward. So you would say yes, this is our direction. This is our direction. If an object is rotating like this, okay, okay. I think if an object is rotating like this, it means anti-clockwise, anti-clockwise, anti-clockwise. If object is rotating like this, then this will be our clockwise, not right one. If an object is rotating anti-clockwise direction, then your direction will be upward. What if it is rotating in the direction of a clockwise? Then just see. Just put your hand. Just put over your hand. This object is going in this direction, no? In this direction. So just close this fingers and thumb is coming downward. So this coming downward is our direction. Okay. Direction. Clear? Anti-clock. If object is rotating anti-clock, so direction is upward. If object is rotating clockwise, then direction is downward. Clear? Just use your rule, which is a right hand thumb, or you can use a screw rule. Examples for this we see angular displacement. We see what? Angular displacement. It is denoted by delta dt. Remember, if you are using d, it means you have a small angular displacement. Okay, a small angular displacement. So we use a theta for angular displacement. Clear? In the chapter of motion in a straight line, we saw for displacement we used to use what? X or R, X. But in the rotational chapter, we replace X by theta. So it becomes angular displacement. Clear? Angular displacement. Now next we have angular velocity. Okay. In the chapter of mechanics, we saw in the chapter of motion in a straight line, we saw that velocity is represented by v, but here it is a different is here we will use a symbol which is omega. So delta omega. Remember, here we are using d, which is for a small. D represent a small. Something is a small. Okay, something is a small. Clear? So omega is nothing but angular velocity. Okay. Then we have acceleration. It is represented by alpha. It is vector. This is vector. And torque. It is represented by just like this. This is also a vector. Opposite of a t, opposite of a j. Okay. Angular momentum. which is represented by z, which is represented by z. Clear? Angular momentum is represented by j. In the upcoming numericals, I think no, right now. In your rotational chapter, you will use this angular momentum. So you use this symbol for angular momentum. Okay. For torque, use this symbol. For acceleration, use this alpha. For angular velocity, use this omega. For angular displacement, use this your theta. Theta. Okay. Let's say in initial, this was over here. The subject was in rest over here. So final just rotated. This rotated by this angle. So this is our displacement. Angle will tell you displacement is this much. It covered a displacement. Okay, it covered displacement. So here angle is telling you displacement of a object which rotated by an angle. Okay, that's why it is called as angular displacement. Here you will see here, okay, it covered this much of displacement. So with what velocity? With what velocity? So that velocity will be our angular velocity. Angular rod we are using, we are adding angular rod because of it is based on theta. It is based on angle. That's why angular rod we are adding. Clear? Angular rod we are adding. Even torque is also based on theta. Acceleration is also angular acceleration is also based on theta. Momentum, angular momentum is also based on theta. Okay. Since it is based on theta, that's why here we are adding angular word. Clear? Angular word. If a velocity, or you can say omega, is constant, it means angular acceleration is 0. Body or object is not accelerating. Object is not accelerating because of velocity is. Don't say velocity, just say omega. Omega is a constant. Okay. Again and again, don't say velocity if you are in the chapter of rotational. Okay. Because it is not a standard form for rotational. Okay. Now let's move towards the topic, which is a parallel vectors. Parallel vectors. It is also very easy. This is very easy. Parallel vectors. Let me write parallel vector. You can see, brother, there is a word which is added with a vector, which is parallel. Parallel means something is parallel to another. Something is a parallel to another object. So here we will not take object. Line, vector. For example, this is a vector. This is a vector, or you can say x vector. X vector. Again and again we are saying a, b, b. Why don't we take another symbol, another letter, so that we can't get over? Okay. So this is our a vector. There is another vector which is like this. Let's name it x vector, not the b vector. Okay. Otherwise it will be boring for us. So this was a vector. Can you say that this is a parallel vector? How can you say? What do you have to say that this is a parallel vector? Tell me, how can you say? Yeah, you say that anybody is asking to you, you just say this is a parallel. A vector is a parallel to B vector. A vector is a parallel to x vector, and x vector is a parallel to a vector. Means if you want to provide logic is, you can say theta is 0 between them. Theta is 0 degree between them. This is logic. Okay. Now definition for it is direction should be same. Direction of any vectors, any two vectors or three vectors or more than two vectors, more than one vectors, should be same. should be same. It will be same when theta is 0. Theta is 0. So direction should be same. Magnitude can be any number. It can be 50. Let's suppose magnitude of a vector is 5 centimeter, and here you can't say that magnitude of a x vector is 5 centimeter. No, because the length has increased here. We increased this length for x vector. So here we can see there is a length of x vector which is more than 5 centimeter. 5 centimeter. 5 centimeter. Now, definition for it is what? Direction should be same. Magnitude can be any number. Magnitude can be any number. Okay. It can be less. X, another magnitude of another vector can be less, can be more. But we don't care about the number of magnitude. Okay. We will care about the direction. If a direction is same, it means theta is 0. Here you can see. If you overlap this a vector on this x vector, theta will come as 0. Okay, this is enough for parallel vector. Now next we have anti-parallel. Anti-parallel, just opposite of it. Anti-parallel. Anti-parallel vector. Don't write vector. Write vectors. Reason is we have more than one. That's it. So for since it is a plural, that's why we use s or es. So we can't take only one vector because it is impossible to create a theta having only one vector with only one vector. Okay, so it says, it explains, it states that angle, I will make an angle which will be always 180 degree. 180 degree. Geometrically, let's try to understand through geometrically. Okay. This is one vector, its name is y vector. Clear? Y vector. Okay. Another vector which we have is like this. B vector. B vector. What are you observing? You are observing that direction is opposite. Direction of a B vector is just opposite of a Y vector. If you shift this B over here, what will you observe? You will observe that angle which we will get will be 100 degree. So this is a exact definition of an anti-parallel vector. Yeah, we know that we can shift any vector parallelly, which will be correct way. Nothing will be changed. Okay, so theta is over here 100 degree. So it says again, I would say magnitude, number of magnitude can be any number, but direction should be opposite. Okay, direction should be opposite to each other. Are you understanding? Direction should be opposite to each other. If a direction is just opposite, it means angle is 100 degree. Angle will be 100 degree. Remember, this angle is providing logic. Okay, logic. Clear. So exact definition for anti-parallel vectors is what? Direction should be opposite or angle should be 100 degree. Magnitude can be any number. Clear? Now next we have equal vector. Next type of a vector which we have equal vector. Equal vectors. What is it? From word you can get clarity from word. Here word is equal, which is added with the vector. Are you getting clarity? It is providing, this is saying that I am equal. If another vector is coming, so that vector should have same magnitude and direction should be same. That is what equal vector is saying. Magnitude should not be more than me and direction should not be changed. If a direction is same, or let's suppose direction of another vector is north, so I will be also north. I will have direction which will be north, not another. So this is vector, okay. Okay. Then x vector, clear. So direction should be also same, yeah. So yes, this is our an example of an equal vector. You can see. First of all, let me explain what is an equal vector. It states that any two vectors, those vectors should have a same magnitude and same direction. This is what is exact definition of equal vector. Now, magnitude, if a magnitude of x vector is a 2 centimeter, let's suppose 2.5 centimeter, not a 2 centimeter, 2.5 centimeter, okay. If a magnitude of x vector is a 2.5 centimeter, so this definition says that magnitude of another vector which is y vector, okay, so this should have also 2.5 centimeter. If it is happening, then you can say yes, this is our equal vector, or it is a definition of the equal vector. So magnitude of this y vector should be also 2.5 centimeter. Are you getting clarity? Okay, we have same magnitude. We have understood the magnitude. What about the direction? Direction, it says that direction should be same direction. Clear? Okay. In my mind, one question is coming here. One question. Question is, can you say that parallel vector is an equal vector? Or you can say equal vector is a parallel vector? Tell me. If yes, then how? How can you say that? If no, then how can you say that this both are not equal? My question is a parallel vector equal to equal vector? Is equal vector is equal to parallel vector? Overall, our final answer is no. Both are not equal. Reason is parallel vector can have more magnitude, less magnitude. Yeah, that's it. But equal vector has a same magnitude. Same. Yeah, direction will be same, but magnitude can be any number between them, between parallel and equal vector. This is what is the difference between them. Okay. So we are crystal clear about parallel axial vector. Before axial vector, we saw about polar vector. Okay, we have seen axial vector, parallel vector, anti-parallel, and equal vector. Now let's see what next will come. Next is note. Since this x vector is equal to y vector, yeah, and you can write like this. Here you can say, you can't say that this a vector is equal to x vector. No, reason is magnitude is not same. In a note, note is if a vector is moved parallel to itself, it represents a equal vector equal to itself. Such a vector which can be freely moved parallel to themselves are called free vectors. Means just you shift this vector anywhere over this board, can you say that yes, this vector is moving freely? It can move free. Conditions don't change. It should not change direction, and it should not increase or decrease magnitude. If any vector is flowing these 2 points, then yes, they can move freely anywhere on a plane. Okay, on a plane. This was mode. We have seen an antipellar. Antipellar. You saw that parallel will have a theta which will be equal to 0. Anti-parallel will provide a theta as a 100 degree. This is fact. This is fact. Now next type of vector which is opposite or negative vector. Opposite or negative of a vector. This is also type of a vector. So opposite or negative vector. Opposite or negative vector.